In this video, we're going to talk about acceleration. So acceleration is defined as a change in speed or a change in direction. Anytime you change your speed or change direction, you are accelerating. Acceleration is measured in distance divided by time squared. Any unit of distance divided by any time, unit of time squared. The one we're most often going to see is meters per second squared. And as I've said in previous videos, if you don't understand what meters per second square means, don't worry. We just have to know that that's what it is. We don't really have to understand why it is at this stage of the game. Just know that meters per second squared is how acceleration is measured. How can you tell if an object is accelerating? All right, so you might be asked this on a question on a test. So one, like we just said, if there's a change in speed or direction, we know that the object must be accelerating. Okay? We also know from Newton's laws that if there's an unbalanced force, if there's an unbalanced force being applied to the object, it is accelerating. Okay? And the third way to tell if an object is accelerating is to look at a graph. All right, so this is a speed graph. On one axis we have distance, sometimes referred to as position, and the other axis we have time. We call this a speed graph because speed is equal to distance divided by time, and we have distance and we have time on the graph, so we can calculate speed. So we know that anytime the line is straight on here, we have a constant speed. Okay, so straight lines mean constant speed. Anytime the line is curved like this, our object is accelerating. A curved line means that the object is accelerating. Okay, now, the good news is you're not going to have to worry about that because a curved line is usually something that we deal with in calculus. So for right now, let's forget about that. So let's go back to our straight lines. Looking at these straight lines here, where can we see the speed changes? Remember from the speed video that the flatter or the less steep the line is, the slower it's going. The steeper the line is, the faster it's going. So if we look at right here, there's a change in speed as you go from here to here. So this is a change in speed, which means the object is accelerating. Right here, there's a change in speed. When the line is flat on the speed graph, the position is staying the same. That means it's not moving. So in this spot right here, there's a change in speed right here and a change in speed right here. Anytime the slope of the line changes on a speed graph, we have a change in speed, which means it's accelerating. We also have another graph called the acceleration graph. And if we said that speed is a change in distance over time, right, distance and time on the two axes, acceleration is a change in speed. That's what we said acceleration was. So acceleration graphs are a change in speed divided by a change in time. So in this one, we just have to put some thought, some common sense into this. So if speed is staying the same, you see that the speed is not changing. We know when speed stays the same, it's not accelerating. But when the speed is changing, the speed is in this case going up, in this case going down. When the speed is changing, then the object is accelerating. So on an acceleration graph, you can see here when it's slanted up or it's sloped down, the object is accelerating. We know that anytime it's sloped down, we means it's slowing down. It's still acceleration. We call it deceleration or negative acceleration, but it is still acceleration. All right, in summary, acceleration is a change in speed or direction. A change in speed can be slowing down or speeding up. Acceleration is caused by an unbalanced force. Remember, that's Newton's second law. How do you tell if an object is accelerating? If an object is changing its speed or direction, it's accelerating, which means that if a car is turning left but it keeps its speed the same, it's still accelerating because there's a change in direction. If an unbalanced force is being applied to it, we know, because of Newton's second law, the object is accelerating. On a speed graph, whenever the line changes its slope, it's accelerating. Whenever the line changes its slope, it's accelerating. And on an acceleration graph, whenever the line is sloped up or down, as long as it's not flat on an acceleration graph, as long as it's sloped up or sloped down, means the speed is changing, so it's accelerating.